Hello, my name is Muhammad Reza from the University of Indonesia, Faculty of Engineering, Electrical Engineering International Program, with student ID 23062548784. Today I'm going to be showing my preliminary assignment number 3, and it's about functions and recursions. So over here I have to provide a video link of me explaining my answers, and here it is. So the first question is, what is a function? And it's a short answer for 5 points. So basically, I've written down that functions are defined as groups of statements which perform a specific function and can be called to do their specified task. This allows programmers to minimize clutter within their code and improve code readability, making bug checking a breeze. So that usually, back in the first a few weeks of in our second semester for basics to computer, before we learned about functions, we only made the code within the main function. So it's going to be very, very long, especially if there are many different tasks. When using a function, this allows us to make it much more readable, since each function has a specified task, a specific function. So it'll basically just look better, and we understand what these functions are for, because it shows us the process, and it's in the name. We usually just give it a name, and it does its stuff. So yeah. Anyway, what are arguments and parameters? This is the second question. Are there any differences between them? So when it comes to arguments and parameters, they're quite different, you see, because arguments are values that are passed into a function when the function is called. So these values are variables which will be used in a function. For example, for a function like this over here, float being the type, multiplication being the name, and float A and float B, uh, the variables are, and for example, if we have variables in the main function as int number 1 and int number 2, number 1 and number 2 will be the arguments, whereas float A and float B are known as the parameters. Uh, and therefore, these two differ in that arguments are usually written into the main body of a code, whereas the parameters are within a function, which are separate to the main code. An example to this would be from my previous assignments, as you can see over here from April. Um, Over here we have a function prototype to be exact, and this is the type, this is the name, and these are the parameters. Whereas over here, when we call a function, it's going to be using arguments, and L, W, and H are values and variables, which are from the, where is it? Yeah, over here. Please enter the value of length, width, and height. L, W, H. This is the input, and this is going to be the values are going to be the arguments for this function. Now, moving on. What is the difference between declaring a function and calling a function? So basically, declaring a function and calling a function differ in that function declarations are usually introductions to functions, which specifies its name, parameters, and return type. This is, well, not really implemented at the top now, but it's usually done wherever you want. If it's going to be in the bottom, you're going to have to use a function prototype, but other than that, it's usually below the main function. And calling a function, meanwhile, is a method used to bring a function, excluding main function, because you don't really want to do that, and its parameters into the main function, where the arguments are used in the call function. So for example, over here, if we want to declare a function, it will be this. Float triangle area, and these are the processes. Calling a function is something completely different, which is this over here. We call a function float AR, which is basically what we want to turn, which is the, okay, my bad. So this is calling the function, and this, whatever value of this rectangle area is going to become area R. So rectangle area is going to be basically the area of a rectangle, and that value is going to be turned into area R. Moving on, what? Oh God, my mouse. What is the syntax for declaring a function and calling a function? So basically, what syntax means is just a structure of it. So when declaring a function, the usual syntax used is the return type. So basically, like int, float, void, whatever. The function name is basically whatever name you give it. Like for example, before triangle area, and these are the parameters. So over here, if we look at the function name triangle area, the parameters will be float width, float height, and you gotta remember to use the same return types, or not something's gonna happen. And this is usually not at the top of the code, but yeah. Meanwhile, calling a function uses the function name with the arguments instead. So instead of parameters, you use the arguments. And this is just an example. When using a variable, the syntax will be variable name. So like for area R, float area R is equals to the function, the called function, function name, argument 1, argument 2. In this case, function name is going to be rectangle area, and the arguments are going to be L, W, H, and yeah. So now this is going into recursion and well, that sort of area. What happens if you call a function within the declaration of another function? So this is going to be touching on recursion. So when calling a function within the declaration of another function, if it is the same function, what will happen is recursion, which will turn the function into what is called a recursive function, which is infinite. However, this will cause the function, like I said before, to call itself until infinity. Meanwhile, if it is used in another function, the call function and its processes will be performed in the other function. So, let's say you put it in the main body, so it's just gonna basically call it. But if it's gonna be in the inside, it's just gonna be infinite. So, moving on, what is recursion? Recursion is what happens when calling a function within the same function, which creates an infinite loop. Though it's kind of a rather abstract process, to me at least, implementing a recursion to your code will allow programmers to reduce the length of their code exponentially. A way to think about this is for loops usually. So instead of using a loop in a code such as for, while, do while, programmers have the knowledge to exploit recursion to make the code more simple, short, and programmer friendly, which will allow bug checking to be much easier as well as better readability. I'll show this later on in the number 10, where we have to choose and make our own code using recursion. Meanwhile, we'll just go to number 7, which is how to prevent infinite recursion. So, since as with all loops, with for loop having for x is equals to 0, x is less than 10, x plus plus. So basically, the value in which the for loop will end is gonna be when it's if x is less than 10. That means when it reaches 9, it'll basically print 9 and then stop. So over here, as with all loops, a programmer should implement a variable or value which will cause the loop to break, else it'll be going to infinity. This is the case for while, do while, and for loops. For recursions, programmers must implement a conditional if statement so that the recursion will be limited to a certain value and not go to infinity. I'll just do this while recheck if you don't mind. And let's move on to question 8. If I can just grab water first. This is a lot of talking. So, in your opinion, What is the most quintessential example of recursion? I have no idea what quintessential means, even though I'm international program. But I know what is an example of recursion. An example of recursion are, since it's an infinite phenomenon, we can use factorials since it follows this sort of structure. So if for f n to the factorial, let's say 10, it's going to be fn, which is 10, then fn minus 1, which is 10 minus 1, which is going to be multiplied for each, and it's going to be going to it's going to go uh, until n minus 9, because if it's going to be 0, if it's going to be fn minus 10, it's going to be 0, and that's, you don't want that to happen, basically. So the limit is going to be 1 for factorials. This goes the same for other phenomena such as the Fibonacci sequence. But for this question, I'm just going to be using one example since it's 5 points. And next, in your opinion, after you graduate from university, do you think you will use recursion in your work? If no, explain why, and if yes, give some examples. So, as an electrical engineer, since uh, we're also still going to be using some programming, I'd say yes, we are still going to be using recursion after graduating from university, especially if we're going to be going to the one of the core competencies of electrical engineering, which is control systems, which uses AI. So therefore, we're gonna be using a lot of programming. So there's that. But other than that, well, out of the top of my head, I can't really think of others. Maybe when it comes to signals, but no. Uh, I mean, recursion to me is a very new topic. So I apologize for my limited knowledge, but when it comes to recursion, yeah, I think it's gonna be used a lot in control systems, especially with AI, and maybe sorry, and maybe in automation. So yeah, so that's that. And now for the final question. Wait, give me a sec. Am I recording? Yes, I am. Choose one of these projects and make your code. Provide comments in every line explaining what that line does. The program must implement recursion. Provide screenshots of your code running. So over here we have my code which uses recursion. So over here we have a recursive function to print binary, the binary calculator. So if x is more than 0, which is going to be our limit. If it reaches 0, we don't really want that. It'll basically divide the number of x by 2 and print the remainder using a modulo. So, and I'll return x. This is going to be the function declaration, and it's going to be called into over here, down here, in the switch case if conditional statement. So if it's 0, it's going to print 0 because, well, the binary of 0 is literally 0. But if it's more than 0, it's going to be printing whatever it is. So for example, we can make it over here, because I have it right here. So this is an example without recursion, and this is an example with recursion. So if we print it out, so let's say we want to input a number that we'd like to turn to binary. Let's say 10, and it's going to be printing 1 0 1 0. So first of all, it's going to be what, 10 divided by 2, and then 5 divided by 2, which is going to be 1, and then and then it's going to be divide by 2, divide by 2, divide by 2, until, so yeah, after 5 divided by 2, it's going to be 2 divided by 2, which is going to be 0, and then so on and so forth until 1 divided by 2, which is going to be providing a remainder of 1. And that's literally this. It's going to be 1 0 1 0. And Yeah, yeah. This is basically using recursion. However, if we use this without recursion, since this is much longer, um, we can see over here, I used two loops, two for loops, and as you can see, it's much longer. So, and also one while loop. Oh God, so it's gonna be much longer. It's gonna use at least, what if we minimize this? It'll be at least 30. Yes, 30 lines. However, using this, it's oh God, it's still gonna be 30 lines, but it's much easier to read, I guess. Um, yeah. Well, I was trying to prove something, but apparently not. So yeah, this is basically just how to use it. Um, it it divides by two and finds a remainder, and then it also divides by two, so it goes down, and it's gonna be stored in an array. And then this is going to be printing the array but backwards because it's going to be divided by 2 and so forth. And yeah, I guess that's pretty much it for my explanation on recursions and my preliminary assignment number 3. I'm going to be signing off right now, and thank you for hearing my video explanation on this topic.